Okay, very good evening everyone, a very warm welcome. My name's Hugo Williams, I'm the Head of School of Engineering, and this is our school's first annual industry lecture for 3 years, which is obviously for reasons that we're all very well aware of, but we're delighted to be back doing this annual event where we bring in experts from industry to give some perspectives on engineering to us all. And we thought we would come back because we had a gap of 3 years. We thought we would come back with not one excellent speaker but two. So there we are. Before I introduce our speakers, a couple of very brief housekeeping items. There are no scheduled fire alarms. The exits are at the back there and down here, but the one at the back there is the primary fire exit. And we'll have some time for questions at the end. Please do everybody join us for some refreshments outside afterwards. So in terms of our speakers, first of all, as Deputy Director of the £318 million Faraday Battery Challenge, Jackie Murray leads government investment to develop batteries that are cost-effective, high quality, durable, safe, low weight and recyclable. So not a complex set of interacting requirements there. Her background is in the steel industry, in environmental regulation and advanced materials innovation. She's recently worked with Formula One companies like Williams and McLaren on diversity in engineering, named as one of Autocar's top 100 women in automotive in 2020, and appointed to the MOD's Land Industrial Advisory Group in 2021. She's a chartered engineer, chartered environmentalist, fellow of the Institute of Materials, Minerals and Mining, and a libraryman of the Worshipful Company of Engineers. As lead applications engineer for LB Foster Rail Technologies, Jackie Butterfield supports rail operators across the UK, Europe and the Middle East to maximise the performance and life of their infrastructure and rolling stock assets by advising on and implementing friction management technologies. And like Jackie, she started her industrial career in bulk steel manufacturing and has worked in a variety of metals manufacturing industries in both engineering, technical and commercial roles. And she's also a chartered engineer and a fellow of the Institute of Materials, Mining and Minerals and Mining. Sorry. Jackie and Jackie are our Royal Academy of Engineering visiting professors. They're funded on a grant that is led by Rob Thornton, our Director of Education, which is specifically there to enhance the coverage of equality, diversity and inclusion and sustainability in our degree courses. And these are obviously hugely important topics for engineering as a profession at the moment. In addition to the support they've been providing to our curriculum development, they've been an enormous support over the last couple of years in supporting staff and students on our second year design and fourth year management activities. For fairly obvious reasons, they've been particularly challenging activities to deliver in the form we've had to deliver some of our teaching in the last couple of years, and their support to us as a school and to the team of academic mentors has been enormously valued, along with our other visiting professors, of course. So tonight they're going to tackle these two huge challenges for engineering, EDI and sustainability, in a sort of interlinked talk. And the idea really is that they're going to give us an outline of how these challenges and opportunities might affect our profession going forward. So I'm delighted to introduce Generation Engineer, Manufacturing Success in the 21st Century.
Oh, good evening, everyone. That was a really nice introduction. Thank you, Hugo. It's really fantastic to be with you at Leicester today. We are slightly like unicorns, Jackie and I. There aren't that many women in steel, so for us, two of us to come from that background is unusual. And obviously, being the first talk after 3 years, it's nice to keep it simple. You've only got to remember one name between the two of us.
Different spellings.
So do you want to take it away?
Yep, sure. Where's our slides? So here we are, Generation Engineer. So what are we talking about? Why are we talking about this? 21st century is a complex place. There's no arguing with that. And there are some pretty big problems to solve in the world and in engineering. So really, being a successful engineer is not just about being a specialist, having the engineering skills, using the engineering toolbox. It's all about interpersonal relationships, how you deal with people, and different tools, different ways of thinking and working that you have to adapt to when you join the working world, the manufacturing industries, or wherever you end up in your career. So you need to be a number of different people to be an engineer. You need to be, in some cases, a strategist and an environmentalist. Sometimes you need to be a psychologist and a behavioural scientist. And sometimes you have to be an epistemologist. I can't say that word.
I don't even know what it means.
Yeah, I'll explain it later. So part of this talk, we're going to explain these ists that you have to be and link them to the themes of EDI and sustainability.
And I think what we're going to be talking about is just how we can engineer trust, because it's such a key element of getting success in engineering in the 21st century.
So why are you bothering to listen to us tonight? Hugo's introduced us as Royal Academy of Engineering visiting professors, but why are we here? Why should you listen to us? Well, between us, and we were quite shocked by this, we have a combined career of 64 years in industry and engineering. So that's a lot of experience that we've lived through and learnt the hard lessons of being a female in a man's world, effectively. So we've had a wide and varied experience in the industry as engineers.
And I think when we first met to talk about being part-time visiting professors together at Leicester, we realised that although we had career paths that started in the same place, they'd diverged. But as we'd done that, actually a lot of the diversity of disciplines that we had come across and the people thinking we'd had really similar experiences. So I had gone into government and realised that was crazy, but actually it was then just crazy engineering on a scale that I'd never come across before. But we both worked in a similar way. We realised that actually to solve problems robustly in this really complex world, in government you've got 67 million customers, by the way, so it gets pretty complex pretty quickly. You have to be a little bit more than just that specialist. Now, that's not saying specialism isn't good. We all need that specialism, but it's the ability to work across those specialisms and really leverage them that's really exciting. It actually means that if you are a specialist, it gets used and it gets seen in the real world.
So what we've tried to do in our career is making being different to the majority of the people that we interact with and work with, to basically to our advantage, and try and make a difference and use our differences as a strength. And we both started in the same place.
Mordor.
Yeah, Mordor. Yes. We are both hobbits, by the way. In the steel industry, and I love this picture. You can feel the warmth coming off it, and there's something about molten metal that you fall in love with, and it never ever leaves you. So for myself, you could probably say that I was born into the steel industry because my parents worked for British Steel. They met there. So if it wasn't for the steel industry, I would not be here. And I started fairly early in the steel industry. So I'm hoping you can guess which one's me. This was me, age 15, at a school work experience at British Steel Teesside. So I was very lucky to have teachers who were very close to local industry and were inspiring in terms of getting kids into the steel industry to get an experience of what it was like, what a career as an engineer or a scientist or a manufacturer was like. And I spent a week basically playing on the steelworks. So we were in the test house, we were doing tensile testing, Sharpie testing, in the chemistry lab here, doing wet chemistry, seeing all the sites, seeing the sparks and the hot metal and the rolling mills and everything. And that kind of, when I think back about it, it's probably that defining moment for me in terms of, I kind of want to do this as a career. So went to university, British Steel sponsored me to do metallurgy at Sheffield, gave me a job as a graduate, and gave me all that kind of educational experience of working in the steel industry. And it was a great education. So when I came back as a graduate, predominantly in the iron making area, So here's me in the hard hat and the orange jacket at the top of Redcar blast furnace, which sadly is going to be demolished very shortly. And here's me this year, age 52, actually on my birthday, at Crouch Tramway Museum, looking at a potential installation for friction management. So I'm not going to be the next Doctor Who, although I'd love that job.
So funnily, I come from Tunbridge Wells, so I wasn't born into steel. But what I did do is go on a summer placement, which I'm sure other graduates around the place have done. And as soon, like Jackie, as I walked out onto the floor, the steelwork floor in the Boss plant, I fell in love with it. Just the scale of it, it was like Land of the Giants. I'd never experienced anything, certainly wasn't anything in Tunbridge Wells like it. So I started up in Scunny as a student on a year out, and I went back actually and put in a gap year so I thought I could go and do an industrial year out there, and loved it, right? And worked in some of the most interesting places. I think that's probably the best way to describe them. You can work as an engineer. And then I went down to South Wales as a graduate and did 10 years, really loving working in technical quality and manufacturing roles on Llanwern. And then I suddenly decided actually I also wanted to really do something environmental, and I moved from there and took a lot of the engineering principles, particularly around sort of balanced scorecards and metrics and KPIs, and took that into the Environment Agency in Wales, and ended up quite quickly from moving from helping them get really good metrics and KPIs to regulating heavy industry in Wales. So almost immediately jumped back to it. And I had some really weird experiences. I ended up doing things like stopping a £1 billion power station operating for 4.5 months. Yes, I'm probably not a favourite person of RWAM power, but that's what happens when you build your station without a permit. Might have got the chief exec the sack actually. But anyway, moving on. I also then went after 14 years there. I saw a job as in advanced materials actually at Innovate UK, and thought, do you know what, that again is something fresh and new. And after 14 years, I was ready to go back into a more materials base. The picture there today, some of those who came on the tour today to UK BIC might have seen some of that going on. That's actually the Battery Industrialisation Centre. And from 2007, I've been either the interim or the director, or deputy director rather, of the Faraday Battery Challenge. I've got 12 million quid extra, Hugo, since I last wrote my bio. There. You might see a skill set in there somewhere. And so I think when we talk about having different careers, Jackie's probably the engineer. And I think I've moved through different career paths and actually realised just how much engineering is broader than I thought it was when I started at university. You know, as I said, government actually is still using PDCA or continuous improvement techniques and metrics and data and evidence, and it is just really interesting to have that brilliant mindset that you get from an academic degree in engineering. So congratulations to Leicester. One of the things I have learned, and I learned it on the steelworks actually, some of the best psychologists and behaviour scientists are some of the shift managers on steelworks. I remember one of them telling me all about how to get momentum on your 300 strong shift, right, when you need to get record tons out the door. And actually a lot of what they were talking about is actually not dissimilar to some of the psychology we would use today. And you may have heard of things like emotional intelligence, right? So you can see we just jumped almost immediately from engineering to talking about emotional intelligence. So this is one of my favourite quotes, and it's really sort of saying, if you can not react but can respond, you can really find your freedom. So I've got a question for you engineers. Hugo, I'm going to put you on the spot in particular. What proportion of engineering decisions that you guys are making, you know, lots of very factual decisions there, what proportion of them are made or based on emotions? There's been really robust studies on all your decision making and how emotional they are or how logic based they are. Anyone want to guess a percentage?
40%.
40% of your engineering decisions. 40. Your engineering maths and you say 40. What do you reckon?
92.
92% of your engineering decisions are based on fact and logic or based on emotion?
Emotion. 92 are on emotion.
The studies show between 90 and 95% is based on emotion.
So right, I'm a scientist.
Which as engineers, you go, oh my God, these women are talking soft, fluffy stuff. And actually, we're not. What we're talking about is your emotions are actually part of your decision-making process, and they're very rational. And I know this because next time you come out of an engineering maths exam and you know you've done brilliantly, yeah, or you know you've done really badly, you're probably making decisions based on your emotional state, but they're pretty rational. You're probably not too far off, right? So what we're trying to say is you're building knowledge all the time, but you're also building what people would call as your instinct or your gut or whatever else. It's all part of multi-faceted, complex information management that you're doing. But what I wanted to bring this bit up in particular is because when we go back to the complexity issue in the 21st century, where an iPhone, for example, or a phone, there's not one person alive that can actually tell you all the engineering and science that goes into those. They're multidisciplinary, they're not even single company devices, right? So you've got teams of engineers globally working to bring one thing that actually works quite nicely when it gets into your hand, right? So you've got such complexity. So what we know is we've got to collaborate. And I work for Innovate UK, we love to say the word collaborate and collaboration. But actually what we're saying is as we increase collaboration, what we would need to be doing is increasing conflict. And as engineering students, I'm sure you get this, and engineers, right, you know you're right, and all the others are wrong, and they're just some of them are just slower to catch up with you, right? And actually, a lot of this is really what we're getting at. So quite often you can be right or wrong, but how you go about it will determine how successful you are. And this is where you start to get this notion of teamwork and trust being really core to manufacturing success in the 21st century, hence the title. So what I've put is, this is a really brilliant, it's called Cynefin, right? It's just a nice MBA style 4-box description of complexity and simple, complex, complicated, chaotic, obvious systems. This made me really chuckle because it's come from a meditation version of it. And Cynefin is a Welsh word actually as well, and I live in Wales, so it's quite nice to do that. But for all the engineers in the room, what's nice to sort of follow is when you and I started work, there was a big trend of looking for best practices. And actually in really obvious systems, that's great. You can go and find best practice and you can slap it in there and it will work and you can apply it across lots of simple systems. As things get more complicated, which tends to be where you know what you don't know, then you have to look for good practice because there's going to be some nuance in there that you don't quite know and you've got to go and find out, but you'll know someone who can do that. So then you're starting to look at good practices because you've got to take a modicum of creativity with those best practices and say, actually, if I take this good practice, I can apply it in. And you'll see this throughout industry and these sort of terms. Then you get to complex systems, and anyone heard of agile sort of techniques and things like that, right? So it's a lovely word that everybody misuses because it's actually very much based on this. It's using a sensing and probing, fail fast approach. Really, it's about how you work and the mindset that you're working in. And actually, very often it's teamwork. Because if you're making decisions as a team, then actually what this means is you can fail faster. If I've made a decision, I've convinced you all it's the right one, and you're all following me because I'm the best engineer you've ever met on the world, and it's wrong, it takes me a lot longer to admit that mistake. If we've made it as a team, gone, oh, let's try that, because we think that's right, you can come back from that faster, right? So this is why you start to get conflict, which is important, you need it, but you need to be able to manage it so that actually you can collaborate. Then you get to the chaotic system. Did I mention I work for government at the moment? And there actually what you have to start to do is it becomes a bit of an art form. So we take and use a lot of sort of complex approach. We have to have a culture where we're feeling like, you know, my job is to make the right stuff to happen for batteries in the UK, right? That's simple, that's my job. And I've got some money to do that, which is great. But actually quite often we're using a novel approach. But equally, what I'm normally doing is saying to people in the UK, you know, what's Leicester's School of Engineering ideas for batteries in the UK, and can we fit you alongside Jaguar Land Rover or McLaren or Williams or someone very exciting so that we can accelerate them, because we've got to work in something that's pretty chaotic, and we've got to accept there's going to be some failure in that, but there's going to be lots of learning. So I put this up not really to talk through it. You'd be glad to know, I'm sure you're just quite bored of engineering processes and tools and things, but these are some of the ones that I'm really used to using, and I'm sure Jackie is too, and most engineers in manufacturing. But there's an issue with them, right? So we can brainstorm why something's wrong. We can brainstorm, cause and effect diagrams. We can do pestle analysis to sort of try and work out what's going wrong. And we can use all these different approaches. But if I'm in a groupthink situation where people around me look like me, think like me, or even pretend to think like me and act like me, then actually what I don't get is the best use of those tools. So what we're starting to see in engineering is use of different tools, where actually you look at a problem as if you're someone different. So customer journey map is actually looking at a problem as if you're the customer. And I've done one recently on fly tipping, well, say recently, about 5 years ago, on fly tipping, looking at why you might fly tip. And actually it's really, really informative in terms of which are the most powerful solutions you can implement. And so that did lead to people getting prosecuted in a bit of a showcase in the area for fly tipping, and drop the response really quickly, because actually it was an educational piece. So you sort of using the tools we had as a regulator to best cost effectiveness to get the outcomes. We also can use things like personas, and personas are really basically making up your customers, but not, so you come up with different personas who might be using it, a 21-year-old engineering student, a 49-year-old visiting professor, but actually what you're doing is really using extremes of the types of people that might be using your product or your service. So they're getting a very different sort of view. You can use that in particular because it strengthens the more your service or product can meet the needs of different people, actually the simpler it is for everybody. So I've done a website redesign based on disability, and everybody just loved it because it made it so much simpler for everybody. It wasn't because it made it easier for disabled people, it made it easier for everyone. So we did want to talk a little bit about diversity. And I get, we always talk about ED&I and talk about ED&I. And actually I want to talk about engineering. So what I tend to like to do is look at the problem first. So we know there's a issue in terms of looking at problems really rigorously from lots of different angles. If we've only got 12% of people employed being female, I know this, every time I get in a car and there's no spot for my handbag. There's a reason I'm in electric vehicles. I have stepped into a Chinese one with a lovely big bit for my handbag. So as a customer, 50% of the people buying cars, there's different thinking, different ways of looking at it. The same if you're from an ethnic minority background. So what if diversity is just better engineering? This is a graph that really made me stand back and think. So this is research looking at the top companies and looking at the boards they've got. And the more diverse the board, what they could show is a significant financial performance improvement for the companies. So if it's by gender, you're getting 25%. And if it's by ethnic diversity, then you're getting sort of 36%. And this isn't because if you have an ethnic diversity, you're 36% better than everybody else. You might think that, and you might be right. But actually what this is really about goes back to some of the most inclusive teams I work with, which are on the steelworks, where actually I was made to feel myself. I wasn't made to feel like one of them. I had to behave like one of them. I could look at things differently, and I was really comfortable in that environment, and then made it feel safe. And so what you're doing there is inclusion, and with inclusion comes potentially some great performance improvements. But when we look at a problem as engineers, we really should look at it rigorously. And one of the things I always get frustrated with is how simplified diversity is expressed as. I had a lovely man on LinkedIn tell me that he had spoken to 4 women that he had worked with in the UK, and all 4 of them through his career had also, there was no problem. And I was kind of like, well, you're a pretty rubbish engineer, right? 4 biased data points, and you've made a massive sweeping conclusion based on where you know there's a problem, right? So what we need to do is understand it better. And the challenge here is, as women engineers, I don't know what it's like to be a bloke engineer. I don't actually know what it's like to be a black minority ethnic female engineer. I don't know what it's like to be LGBT in this community. And I actually don't know as an individual what you've gone through. I know what I've been through, right? So I can then go, okay, so I can understand this problem and we can do some more analysis. This one's great because this one actually shows that you can assume other people have similar experiences. But when you're the only one of a diversity in a group, actually you'll experience worse. So you can be a bloke and have a hideous time with an individual or a team. And that's, I'm really sorry you've been through that. The probability is if you're in a group of men and you're female, you'll have a worse one. If you're a bloke and you're in a group of women, you'll also have a worse experience. But this is because actually we like to project experiences. And so all I'm doing with this slide is really saying, okay, so actually we can start to look at this in more of an engineering way. We can think differently. We can apply those root cause analysis. We can start to think about the data more. And it's been great to work with Rob and Hugo looking at actually when are people really enjoying the course? What points do different groups find it more challenging? Can we do something different? Being more rigorous, not just assuming. And this I always like to put up. We've got some senior members, academic members of the community here. And I love this. This is a cutting edge psychology. So you're going to walk away as specialists on this. And actually, it's really key when you're in collaborative situations, right? You might not feel that you're really up to par with your senior academic chancellor or vice chancellor. So actually, you might walk in thinking, oh my God, we walked in earlier going, what are we doing? I'm speaking to you lot. And it's kind of like that. I'm not okay. You guys are okay. The academics here are far better lecturers, right? And actually, it's not a constructive life position or position to take in any conversation. I could walk in as a member of the Tory party and senior cabinet minister and tell you all that you're not okay and I'm fine. So that's a different life position. I'm not a member of the Tory party or cabinet minister, you're glad to know. But it's very much a kind of, it's a life position you can also take. But again, you're not going to get the most constructive positions. We can get into, in teams, you've probably seen it, I've seen it, where teams get into I'm not okay, you're not okay, it's a hopeless sort of position. And what this is really saying to us is these positions that we actually really commonly take. As a woman, I've been told, you're really good, you need to push yourself forward, you can beat them. And it's like, so you just want me to flip from that position to that position, it doesn't feel quite right. And then we all actually do know that when I'm talking to Hugo or Rob or pro vice chancellors and very clever people, if I can look at them and say I'm okay and they're okay, then we can have a really healthy conversation. So if you've got an interview coming up, some of you might do, it's a great little mantra to have walking in, because when you're in that position, you can see much more. And one of the examples I give is Nigel Farage, right? So I'm not a massive fan. Sorry if you guys are. I'm not a massive fan. But when I take an I'm okay and he's okay position and think about it, I can see that actually he's changed history of the Great Britain and he's not even an elected member of parliament. So there's probably not a more successful politician in the UK today, which is quite a galling position. If I then say, okay, so I'm okay too, then I say, well, actually, I should own some of this as well, in terms of, being better able to communicate science, engineering, and everything else. I think I'll shut up now.
Yep. Have a drink. So second, the kind of second-ist is the strategist and environmentalists. And this is a quote that actually Jackie found, although it's not strictly related to sustainability, it does kind of sum it up in terms of the challenge of climate change and all it brings with it. The tasks are pretty broad, they're pretty fuzzy, it's not well defined, but we know it's there and we have to solve it. So in terms of this, what we're talking about is being an engineer, and not just being an engineer, but having to have or develop a mindset related to sustainability and have that always kind of there as a almost there sitting on your shoulder in terms of, well, what am I doing in my engineering, in my career that is affecting the way that the world is now? So if you look at the definition of sustainability, this is the standard definition that is always trolled out in terms of meeting the needs of the generation without compromising the future. And then following on from that, sustainable consumption is, what are we using? How are we using products that respond to our basic needs as human beings, that give us a better quality of life, but minimise the use of natural resources and toxic materials, as well as emissions and pollutants, and all of those things that are related to sustainability and climate change. So sustainability and sustainable engineering, following on from that, could be defined as engineering design of products, processes, services which meet those criteria of sustainability and sustainable consumption. So why is sustainable important? Stupid question. The truth is out there. I mean, this report came out last year, which was a pretty damning report in terms of the physical science of climate change. And there were a number of key conclusions made in this report, which clearly state that the surface temperature of the Earth is rising. The last 5 years have been the hottest on record since 1850. Sea levels are rising. Human influence is very likely, 90%, the main driver for the global retreat of glaciers since the 1990s. And hot extremes of temperature are becoming more frequent and cold events are becoming less frequent. So the science is there. Following on from that, the updated report issued fairly recently went even further to clearly state that human society causes climate change, and therefore action is required now. And there was all this talk about 100 months to take action. That's all we've got before it's too late and we pass the point of no return. And so adaptation and resilience is critical, and that's all linked in with engineering in terms of how you design and use and manufacture products. So Jack's going to talk about this from a governmental kind of point of view.
Well, not really. It's really following on from what you're saying. So I work on net zero, I work in electrification, and the reality is, if you want to be successful in engineering, you better recognise that it's being legislated for. So whether you agree with the science or not, it's there, and you're going to need to be successful long-term products that are going to actually help reduce climate change. And I think we all want that, really. What's really interesting is I had an automotive engineer come up to me about 3 years ago and go, this government's crazy. Like, there's no way the automotive industry can hit the targets that are being set. What sort of evidence are they basing that on? And I was like, climate change evidence, actually, and CO2 in the atmosphere, at which point, oh, because actually all of a sudden it makes sense, right? So this is kind of what we're saying about the complexity. Through his lens, they've done so much to bring down emissions in automotive that he couldn't see that way through for his product. What is interesting is the UK has actually legislated. So we're the first big major economy to do that. And we will bring greenhouse gas emissions down to net zero by 2050. That's massive. Focus big time on transport at the moment. You may have noticed that, and that's because you might notice from my career, actually for the last 25 years, it's been big focus on industry. And now we're sort of seeing real transformational change. So it's an exciting time actually to be an engineer. This budget that's in front of you can be looked up, and you can see actually how that breaks down into the different areas. At the moment, transport now makes up about 27% of the UK's emissions for CO2 or their equivalents. And so you can sort of see how the government's trying to get down to where we're meaning to go.
So what's this got to do with engineering and all the people in this room today? Again, another definition, engineering is the creative application of scientific principles used to plan, build, direct, guide, manage or work on systems to maintain or improve our daily lives. Therefore, engineers are problem solvers. And climate change is perhaps, well, not perhaps, it is the biggest problem of all that we're currently facing. So therefore, we have a massive part to play in that. And so that's why I feel it's important that engineers develop this sustainability mindset in terms of what are my actions doing in terms of sustainability. And we need to access and use sustainability tools in our engineering. But this doesn't just apply to engineer, it belongs to the sales team as well. They need to think in those terms as well. And we need to develop this strategic and system thinking. So this is where the strategist comes in. And also use tools and mindsets like life cycle thinking. So thinking about the products, how are you manufacturing it? Where are you sourcing materials from? Where are those materials coming from in the world in terms of transportation? How are you using that product? And then at the end of the product's life cycle, are you reusing it? Are you recycling it? How are you getting into the circular economy of your products?
Jack, I've just realised there's an advantage to being old. We can look back and actually see that actually for me in transport right now, I get more questions about sustainability than ever before. I hear procurement people saying I need to know what the life cycle impact is of the products, of the materials. And this is the first time I've actually really heard it to the depth that it is for electric vehicles. So it's really interesting, as having worked with automotive for a long time, to suddenly hear this culture shift. It's out there.
Yeah. And the final point is in terms of whole life costs. A lot of my role as an applications engineer is dealing with customers, coming up with solutions for them. But the one question they ask is, how much is this going to cost me? Not just to buy it, but to run it, to maintain it, to recycle it, to scrap it, and the whole thing. So I've had to learn those tools in terms of looking at things like reliability assessment, maintainability, safety, all of those kind of RAMS analysis, life cycle costing, and be able to reflect that back to the customer and say, yeah, you want to use my product because in the long run, it's going to give you the greatest benefit, both technically and financially. So customers are getting a lot more demanding in terms of the level of detail that they want, and certainly in terms of sustainability. And there are a number of business and regulatory drivers. So again, back to government, this procurement notice, policy note was published last year. So this applies to all government departments. So any government department or non-departmental public body that is putting a competitive tender out there for anything above £5 million. So when you're in rail, a lot of the projects are way above this sort of level of funding. So even to be considered as a bidder, you have to have a carbon reduction plan. You've got to commit to achieving net zero by 2050. You have to report your carbon emissions, your scope 1 and scope 2 emissions, and some of your scope 3 emissions, and by which the scope 1 and scope 2 emissions. Scope 1 are your direct emissions, so it's energy usage, it's electricity usage. Scope 2 is more indirect, so it's transport, so you know, how much diesel do you use in your company cars, how much diesel do you use in your forklift trucks on the shop floor, and your scope 3 emissions, which are by far the largest amount of emissions, are your supply chain, which is the hardest part to define, but it's the most important. And so you actually have to look in detail at your supply chain, and that brings with it your product design, your manufacturing, where are you getting your products from, your raw materials from, and you've got to have all of this to be even in with a chance of bidding.
Yeah,
So
and it's tough doing that in engineering design
Yeah.
anyway, and then you've got to do that.
yeah,
Yeah.
And most companies, they haven't got a clue where to start.
Yeah.
So it's big business if you're a carbon consultant at the moment, because people are knocking at your door. And customers are doing the same. So from my own sector, the rail sector, Network Rail have an environmental and sustainability strategy. So they're putting their house in order and doing all of their due diligence in terms of their emissions. But they've put it then onto their suppliers, of which I'm one, saying that our supply chain, 75% of our suppliers, you must commit to having science-based targets for net zero by 2025. So they've got their priorities in terms of low emissions, reliable, resilient to climate change, improved biodiversity, minimal waste, sustainable use of materials. And they've been educating the supply chain over the last year in terms of what they want us to do. So really, there's no choice. You've got to do it. Otherwise, you go out of business. You won't have any customers. So you really have to think in terms of the whole system, in terms of how will my product system, process, design influence the overall system it's impacting in. For me, the railway system. And how does that affect the triple bottom line of sustainability in terms of social, economic, environment? So you kind of have to have this mindset in terms of when you're looking at things, and then bring that into life cycle thinking. So looking not just at the technical aspects, the functionality of the product, but looking at the environmental, the social performance of the product, the process over the whole life cycle. Still while making some money, because at the end of the day, if you're in manufacturing, you're here to sell things. So you've got to still make money at the end of the day. And looking at the product cycle in terms of the whole life cycle from start to finish, and reuse and circularity. So a case study from the rail industry. I'm in friction management, so I'm looking at asset management, asset protection in the rail industry. So from my own company, we have a water-based material called Caltrak that we apply to the top of rails, which has the following effects. So we're applying the Caltrak to the rail, the trains run over it, carry it down the track, so you get this lovely, nice spread of what looks like grey emulsion paint. And this has very unique properties in that it controls the coefficient of friction between the wheel and the rail to a very narrow band of between 0.3 and 0.4. The reason for that is if you go anywhere below that, your trains aren't going to stop and they ain't going to start. So you've got to control that coefficient of friction. So this is a highly engineered fluid. I don't know the recipe of it. It's held by my colleagues in Vancouver who make it for me. But what this does is it has an effect because you're lowering the coefficient of friction, and he's got his tribology radar on there. You're reducing the wear of the rails. You're reducing rolling contact fatigue damage to the rails. You're also, so here's some rolling contact fatigue damage here. So you've got very fine cracking on the rail. And what happens if you don't control it is you start getting this horrible spalling. So basically your surface of your rail falls apart. Actually, that's probably the best case. If it doesn't do that and you still have this cracking, the danger you have is these cracks, which start off very, very shallow, suddenly they decide to go like that, and you basically have no rail anymore. And that's how the Hatfield rail crash happened in 2000. And about 180 pieces of rail were left where there was one originally. It also reduces rail noise because it affects the frictional forces in the wheel rail interface, So you don't get that horrible squealing noise as you go around a corner and you're kind of doing this, and it doesn't, and you don't get complaints from the neighbours, which Network Rail frequently do. Because you're controlling the friction, it reduces the lateral forces in curving, so you get a better ride quality of the vehicle. It improves the vehicle steering, and it can also be used to protect special track work, so switches and crossings, which are very expensive bits of kit. And it can also help you with energy consumption because you're lowering the coefficient of friction, you're lowering the resistive forces in traction. So you're actually using less energy. And certainly this product in freight, where you're basically starting at one side of the country and going to the other and not stopping in between, you can get fuel efficiencies of between 10 and 15%, which, when you look at how much diesel, particularly Class 1 railroads in the United States, 10 to 15% is millions and millions of dollars a year. So it's kind of a no-brainer, really. So that's the functionality of it. All great. So just very quickly, how you actually get it out there. This is a bit of kit which we call our Protector 4 unit. It's an American company. Which is essentially a pumping system. So you have a product tank, you have a steel cabinet, in there you've got a product tank, you've got a battery, of course. You've got a pump system, you've got a digital control system. It's powered by, or the battery is recharged by a solar panel, renewable energy. And then basically you pump it out onto the track through hoses. Bit of smart wheel sensor here, Hall effect sensors, so it detects the passage of the rail vehicles, and it says, counts the wheels and says, yep, you need to pump now. Start the timer again. So not particularly complex bit of kit. So digging a little bit deeper in terms of the sustainability impacts of it. So how does this affect the triple bottom line? So top level is you get longer rail life because it's not wearing, it's not getting damaged, but you're reducing noise. You're improving your ride stability and your comfort. So they're your social aspects, because your corporate social responsibility comes in there, because you're reducing noise to the environment, you're reducing noise to your neighbours. You're making it a lot better for the people actually sitting on the train and riding on the train, not doing this. In terms of economics, they're fairly simple to understand. In terms of you're reducing your maintenance costs because you're less damage to the rail. You're reducing replacement costs of replacing the rail, because the rail will wear, the profile will change, and eventually you're going to have to change it. You're reducing manpower costs. You're reducing energy costs. There's also a safety aspect in there, because you're not having to put people out on track and put them into a dangerous situation where they might get hit by a train. And then you've got the environmental aspects, which you've got reduced fuel, electricity input for your vehicles. You're reducing the steel consumption. You're reducing noise pollution. You're reducing the travel for people to get to maintain the rail. So you're lowering diesel emissions, fuel emissions, and you're using a renewable energy source to power it. So these are all kind of things that I might not think of those to start with, but they're all selling points for your customer. So just doing a quick calculation, and this is very generalized, I've not validated these numbers, this is just a quick calculation just to kind of illustrate it. 500 metre length of rail curve, CEN 56 is the rail profile, which is 56 kilograms per metre. That's 28 tonnes of steel. Protector 4 cabinets, 80 kilograms of steel. Just the carcass of the, so I've not looked at the solar panel, the battery, control system or anything. Average life of rail Without friction management, 5 years if it's a severe curve and you've got severe wear. After friction management, 10 years. So you're doubling your life of the rail. So in those 5 years, to produce those 28 tonnes of rail is approximately 94 tonnes of carbon dioxide equivalent. So yeah, we've got to do the steel for the cabinet. It's around 270 kilograms of steel. So you balance, by doubling that rail life, you're saving 93 tonnes of carbon dioxide going to the environment. So there are kind of different levels that you can go to in terms of, and you can go into real detail in terms of life cycle costs. I've not looked at recycling, benefits of steel. I've not looked at the manufacture of the solar panel or recycling the batteries or anything like that. It's just a very simple, but it's powerful numbers. So again, I'm not going to go through these in any detail, but there are a number of environmental analysis tools. So life cycle analysis, just one of them. So you can look at material flow, you can look at carbon footprint, you can look at monetary things like cost benefit analysis, total cost analysis, as I mentioned earlier, and life cycle costing, all of which customers are becoming increasingly interested in. And so you need to kind of have these tools in your back pocket so you can, because the sales team have no idea where to start in terms of, it's the engineers, it's the people who design these products that can come up with the data that is required for this analysis.
So I think, Jack, we've got 7 minutes.
No chance.
Yeah, that's okay, we're lecturers, right?
Yeah. You can leave if you like. Yeah, so the final part, you'll be so relieved, is a quote that again Jackie found, and I'd not heard this quote before, and this section is all about knowledge and knowledge management. Do your best until you know better, then do better. And actually thinking about it in the car coming down, I'm thinking, actually, yeah, that is a very good mantra to live by. So this very final bit is talking about the whole piece about knowledge management. And epistemology is the study, the philosophy of human knowledge. And knowledge management is how you create, share, use and manage knowledge of an organisation. Well, not just as an organisation, but as a person, as a human being, but particularly related to knowledge management.
I guess if you're a student, it's the how you get knowledge quite quickly when you've first gone into somewhere new, and we've just bombarded with telling you need to be omniscient and all-knowing about everything ever.
Yeah.
So we wanted to just talk about that, actually knowledge is around you,
Yeah.
and how to tap into it and how to contribute to it, because you're valuable.
Yeah. Most important is how to put the kettle on and how to use the photocopier.
That's good. Yeah.
So why is knowledge management important? It's fundamental to a business. You need to capture and exploit your knowledge to a competitive advantage. But it's especially critical for engineering and manufacturing because you've got complex data, you've got information, you've got all of this wealth of product and process and manufacturing knowledge that you need to be able to exploit and learn from, in order that you don't have to reinvent the wheel every time you start a new project. As Jackie said, newly recruited staff need to get up to speed very, very quickly to become effective in the organisation. And in today's fast-paced environment, you don't have the time. You've got to be very astute in how you become very familiar with what you need to become familiar with quickly. That sentence sounded better in my head. But there's also a drain of knowledge as well, particularly in the traditional industries. I mean, from our experience, the steel industry, when we were in the steel industry, all of the technical people, all of the people with the highly knowledge were all middle-aged grey men.
You're all now retired.
Or dead. sadly.
Thanks for that, Jack.
Yeah. Yeah, unfortunately, a lot of my colleagues, my peers, are now no longer with us, and all that knowledge is gone. So, but there's also quite a quick staff, you know, some organisations have a very quick staff turnover, and that knowledge has to be captured in some way. Otherwise, you do have to reinvent the wheel every time you start a new project. And it's essential to capture both the explicit knowledge, so the documentary stuff, the clear information that you have, but also the tacit knowledge of the organisation and its staff. So the tacit knowledge is the stuff that's in people's head, the stuff that nobody else knows, the experiential stuff. And this table just kind of compares the two different types. So the tacit knowledge is how you adapt to things, how you deal with new and exceptional circumstances, how you think on your feet, how the know-how that, you know, yeah, I've had this problem before, this is how we solved it. Or I've seen something similar, we could try this. And it's that knowledge that is the most difficult to capture because it's unconscious. You know it by instinct, going back to instinct, and it's very, very difficult in some circumstances to explain it to somebody. Whereas explicit knowledge, it's there, it's on the page, it's written down, it's in a database, it's clear, it's conscious knowledge. And the challenge is, how do you make the unconscious conscious and use that for future generations, if you like, of employees? And it's kind of all linked into asking the right questions and becoming almost an investigative journalist in some, so knowing which questions to ask to actually extract that knowledge. And we've both been there in terms of our career, in terms of knowing who the experts are, and they're often the most curmudgeonly people that you've literally got to get to know them and tease out that information. So that's where your diplomatic skills often come to the fore. So it's about asking the right questions, and Jackie's got an excellent case study.
I thought I was going to talk about intermetallic formation in galvanil baths. No? Oh, okay. So no, this is one from when I was working in galfsteel, and I was a student. I was a new graduate, so knew very little. And actually, I was doing some work on the business management system, which is the quality control system, and it was writing and updating some things. And I was trying to get the curmudgeonly pot operator, the senior guy on plant, to explain to me how they could control the intermetallic formation. And he was talking to me about how they were adding, the iron was coming in, reacting with zinc and creating top dross, and then they would make it zinc by adding aluminium, and it's all a lovely materials peritectic sort of reaction processes that they were playing to. Now he got it, but not in an engineering or scientific way. And there was a new guy alongside me who was being trained up, and he went, yeah, but my mate works down at the aluminium plant where they're coating aluminium onto steel for exhaust pipes, and their pot, their molten metal, is held at sort of 690, 700 degrees. So when we're putting aluminium bars in, why is that not? Why are they melting? And the guy who is the pot leader, the curmudgeonly one, said, that's because it's dissolving. And then he went on to describe what was happening with dross mechanics and temperature fluctuations in the bath, using tea and sugar to describe those concentration curves and how they change with temperature, and how you could then play with the whole mechanics of the bath to get a period of time when you had iron coming in on the strip and reacting, but the dross formation was so low that you could make exterior panels that were the high priced premium product off the line, so the guy could understand it. So the reason I'm telling you is because it wasn't me. I didn't come up with this, but I was listening, and I really liked the answer. And I started to realize actually my value add could be writing this down. And so I worked with the technical manager not only in the UK on the Newport line, but also in the Dutch one, and we came up with a really nice sort of set of hand drawn using PowerPoint or whatever else, sort of cup of tea analogies. So people could understand if you're putting more aluminium in and if the temperature is fluctuating, just how those concentration curves were influencing. And so I think the point we're trying to say is sometimes it's finding those things where you can add value, where actually that's where you'll overcome, that's where you'll get the diplomatic. I've never met many engineers who aren't actually really happy when things get fixed or made or built or move forward. It's kind of why we do what we do. So I think that's really important to sort of reflect on that. So even if you were brand new and you knew very little about engineering, nothing about Gal, you could have sat there and done the same thing and gone away and find out.
So there are a number of tools, again, this toolkit that you've got. I mean, for me personally, walking into the steel industry, the most useful thing was this kind of peer training and mentoring, which was affectionately known as sitting with Nelly. So literally just sitting with the operators or the shift managers and actually observing, having a cup of tea with them, just asking them the questions and saying, you know, what's happening there? Is this, you know, what would you do in this situation? How do you know that something's going to happen? I mean, on the blast furnace, you know, the operators had an instinct when something was going wrong because they almost kind of knew what the furnace was feeling because you could look at the pressure, you could look at the temperature, and they're going, all right, okay, yeah, we're heading for trouble here. Let's back off a bit, and kind of building up that instinctive knowledge and absorbing it, but then trying to extract that and use that and capture it and codify it. You can use tools like structured interviewing, which I've used in previous roles where I've known that an expert is going to retire in the next 3 years and he's the only person in the company that has the detailed application knowledge. So putting together a systematic number of questions in terms of, and getting, you know, drilling down into the detail, you know, why, and capturing that either by recording a conversation and then transcribing it. And then you can develop that into your management systems, your documents, your process flows, process mapping, method statements, safe working procedures, even to kind of future-proofing things like technology roadmaps for looking at where you are now, where do you want to be, how are you going to get there. Same applies to risk management and risk mapping. And then kind of bring it even down to project management and how do you capture your lessons learned from a project and then learn from them. And all of these things require diverse and multidisciplinary teams to actually achieve that, and collaboration first and foremost.
I think going back to that diverse point, actually both of us would have loved sitting with those guys that knew it all. I didn't really want to speak to you because when they open up, oh my gosh, she knows so much more than when you walk away at the end of the shift, right? And one of the things that I talk about, and we're both as engineers you start to do, is this oriented collaboration piece, and it's quite a nice way of describing what we do. So your professors will go to conferences and they will talk phenomenally clever stuff, and they'll call it blue sky thinking, right? And that's what happens at conferences. You'll have these big social networks, I'm not talking about Twitter, I'm talking about actually at those conferences, people really thinking about wild and creative ideas. And then you go back to your day job. We've actually got to get some tasks done and things delivered. Somewhere in between, we start to see something called a community of practice. It's worth Googling if you're out in work in particular, because actually this is where your practitioners start to step out of their teams and work together on things. And it tends to come about where there's a need, right? And a community of practice is where people can listen into those experts talking about stuff that isn't the day job, and they can learn, right? And it comes from, the research into it comes from research realising that people knew more if they sat near the coffee area because they'd overhear information, right? So, but what we also do is we have quite standardised things. So you heard Jackie talk about working practices, safe working, you know, your ISO 14001, your statements of work, whatever it might be. You can also, where I am, we've been sponsoring things like British Standards institute do some work where we get experts out to really work on battery safety, for example, for vehicles. So that's exciting. We want to do that. We want to know more, and we want to be able to store them very safely. And actually, by pulling people together, and engineers talk health, safety, and environment, they will come forward, because ethically, I would be really angry if I found a British engineer who felt that they could make money on the back of health, safety, and environment and not sharing it. I don't find many ever that do. So those communities of practice really start to leap forward much quicker knowledge as we move forward. So it's just really interesting to know how you can get those incremental improvements and learn, but also why it sometimes feels disjointed between those very clever people at conferences talking about the next big thing.
Yeah, and just a final kind of example of that is again my own experience of developing European standards for railway systems in terms of friction management. So I sit on the working group 38, which is the working group that is looking at the EN 15427 series of standards, which have just recently been published actually. So this group is a really kind of diverse group of people from railway operators all across Europe. So UK, France, Germany, Austria, Switzerland, Netherlands, rolling stock manufacturers, big players like Siemens and Alstom, but also rail suppliers, so obviously the supply chain. So we've got rolling stock equipment, people who make braking systems, sanding systems for vehicle, but we've also got friction management people. So I sit on this group with quite a few of my competitors, which you might think could be quite a spiky relationship, but we've got a common goal to develop these standards. So we kind of leave our commercial hats at the door and just purely talk the technical aspects of how do you get the best out of friction management in railway systems. So we've all got our kind of private different agendas and priorities outside of the room that we're in, but we've just got this one common goal to develop industry-wide standards. So that's kind of an example of a community of practitioners, if you like, community of practice.
It is indeed. And what's funny is the joy when you speak about things like that, Jackie. You guys out in the university might not realise how much joy comes from developing a really good standard, but it is really quite sexy in the end. Yeah. Okay, so this is final, and we've run over. I'm really sorry about that. But we wanted to sort of say to you, we know the 21st century brings a level of complexity into engineering that's just unprecedented. You are moving out into a world that's more complex than it's ever been before, but you can capture and build on existing knowledge by learning from the people around you, really opening up to those with different backgrounds. Remember the I'm okay, you're okay when you're talking to somebody who you might feel has got a different position to you, but stay in that I'm okay, you're okay, because actually you'll get those really constructive conversations going. And it's definitely easier to lose more knowledge than you think.
So yeah, we've talked about collaboration brings conflict, but we need those conflicting opinions because they drive creativity, and we need tools and new skills so that we can become more exploratory and adaptive without losing that core engineering knowledge and rigour and professionalism. So, but we also need to think about the whole system as well, which means doing the right thing right, because being an engineer today is that sentence doesn't make sense. Because engineer today is what? You wrote that one.
Because engineers today are manufacture success.
Yeah, exactly. And help save the planet. So
thank you very much.
Thank you. Kind of collapsed in the heap at the end.
Thank you both very much. That was really, really eye-opening. Lots of interesting thoughts there. Can I throw the floor open to any? In fact, Rod's going to.
Oh God.
Compound questions. He may even have an opening one. We'll throw the floor open to anybody who has any questions.
Microphone runner.
Okay. So, anyone got any questions for Jackie and Jackie they would like to ask? Don't shout.
Scared.
Yeah. Where's he got?
He's going far away.
Oh,
I got the wrong person, right? Okay. So first, many thanks for sharing your experience with us. We talk about engineering principles or in university of knowledges, and also more importantly, kind of personal, interpersonal skills for the people getting into industry. Probably I would like to probably have your view and what, you are the visiting professor to our school. What is your view and how could we improve or merge that kind of interpersonal or personal skill into our engineering teaching at undergraduate level?
I don't know about Jackie, but actually for me, when I met Rob and I met Hugo, and we were talking about this on the bus just a moment ago, actually the culture you have here is one that I really like. It's one that I think people can thrive in. And the reason being, actually you're a small engineering school in a red brick Russell University, and actually you haven't got these massive engineering centres, and I went to Manchester, I don't recognise it, to the university that I actually attended before they discovered graphene, for example, right? But actually in that is a real strength. You can be more agile, and agile in that culture, that ability to work together, have a common purpose, and really contribute to each other. And I think one of the things that I'm not sure ever always comes across when we talk like this, it's really important to have introverted specialist engineers who have the skills to step in and do some conflict management or put their points across when needed, and you then also need the other types of personalities and the extroverts like myself. I'm not sure Jackie's quite as extrovert as I am, bless her, but or my problem probably. But actually you need these groups, and we need to recognise it more fluently. And when you can articulate it and you can explain to people just how useful that is, you start to be able to leverage it. So I think a lot of industrial partners would be interested in Leicester because it's not the Cambridge, it's not the Oxford, it's actually someone you can work with rather than have to be wowed by. It's a different culture, and it's a much more 21st century culture.
Sorry.
No. I was just going to say I don't really have anything further to add to that. So we're here. We like it. Yeah.
So what I was going to ask about was the three circles to do with the conference level stuff and then your day-to-day work stuff. So with what's gone on in the world in the last 2-3 years, do you think we've got a problem now that we're doing a lot more remote working, people working part-time in the office, that you talk about learning from being sat near the coffee machine? Do you think people remote working, so I graduated from here, 2 years ago now, and I work in a engineering consultancy firm, and I might see my colleagues once a week if I'm lucky. Do you think there's a risk that people, young engineers today, are going to struggle to get that information and that kind of central bubble of working with senior engineers? Now you're not going to see them on a day-to-day basis. You can't sit and share a desk with them for an hour when they're going, oh, I'm doing this really interesting project, come and have a look.
Absolutely, and I felt that within my own team going through the COVID situation, and the way that I mean, I'm noticing it now that we're back in the office, albeit not completely full time, but the engineering team gets in the office 3 days a week. So the engineering team is together, and I've noticed the difference since we've come back into the office in that there's a lot more cross collaboration and, oh, I'm doing this, what do you think of this? Or I've got this issue, have you got any ideas how to solve this one? But what we had to do during lockdown is we had to put mechanisms in place where we maintained that contact. So predominantly on a social level, because everybody was working from home, they were very, very isolated. So we had the normal kind of a daily catch up, right? What are you working on? Have you got any issues? And that sort of thing. But we also had the social aspect as well. So for our team, we still do it actually, we have Friday fun. So we just have a half an hour meeting and we just have a laugh, do a funny quiz, play GeoGuessr on, or City Guesser, and just literally just have a social time where we're bonding as a team. And, if anybody's, wants to talk about anything outside of work or anything in work. It's kind of, it's just maintaining that social contact, because if you don't have that social contact, you can't work collaboratively. I'm tired. Been up since 6 o'clock. Yeah, collaboratively. Yeah, I can say it now.
With I can imagine being in a consultancy as a graduate right now is quite painful. Yeah, and I think, you know, Jackie's just described what I would call social capital, and without the social capital, those things we were talking about is very hard to go and do. I think it's not all doom and gloom in that, you know, the world has moved on technology-wise. We couldn't have gone through the pandemic 15 years ago. Nobody would have been able to talk to each other except on the phone. But I think it's the recognition of how important those human factors are to us as engineers. You know, that if 95% of your decision make on something on an engineering project actually is emotional, recognizing that actually you don't feel you've got that relationship quite in the right place is actually massive to the performance you'll achieve. So like Jackie, it's recognizing Friday fun, definitely. So actually, ironically, I don't know if you all knew this as engineers, but Friday afternoons is silly season in all engineering businesses. It's where you start to get the giggles as teams. But it is that sort of getting to know people. And so one of the reasons I think we find it so important to talk about it and the complexity of the 21st century, because this is actually part of it, isn't it? So, you know, you can go on SharePoint, access any files, but understanding is a different thing, isn't it? So being brave enough to ask for support, being brave enough to go to the older generation and say, I just don't get this, becomes harder, but it is still doable. And I think that's really the challenge for you guys coming into the industry, is to make sure that those barriers are real, not also in your head, and be bold. I mean, if we can walk into pulpits on a steelworks at 21 years old from Tunbridge Wells and make them all tea, right? It's those sorts of things that are actually really scary, and step into them, because that's where actually your moment to heal. And I think we'd also be here for you. So if you want to bounce ideas off us, you know, let's do that too.
So we have one question online as well, which I've just spotted. So with regards to sustainability and sustainable consumption, what is sustainable today may not be considered sustainable in future due to unpredicted increases in the user population. So how do we as engineers realistically consider this fluctuation and adapt to it?
Oh my God, that's a long question. Who is that? Anonymous?
Yeah.
I'm chuckling because I work in the nuclear industry.
It's
sustainable to the bad guys.
Yeah.
I don't even know how to begin to
I think that's a
answer
real
that.
government question, right?
Yeah.
So it's going back to that, the Cynefin, right? That's a chaotic system.
Yeah.
And so there isn't an answer to it, right? What there is the ability to try things and fail, be really sensible, probe things, really study, find out where you, it's really about knowing what you don't know, right, as much as you possibly can, and being really honest about going, you know, as a government, we don't know how we're going to do this in electrify marine, right? So what can we do? How important is it? Can we worry about it now? Can we worry about it later? So it kind of still fits into an engineering discipline. It's just that unknown. And actually, perhaps that question's a good example, right? Because we have to front and go, we don't know.
Yeah.
And that's the answer.
But it's about adaptability and creativity and looking at those issues and applying your creative problem solving and the wacky ideas, and on a Friday afternoon.
Yeah.
Just
in fact, there's engineering companies around the world that I was in 3M, and they will give you 15% of your time just to go and work on whatever you want, to allow you to be creative, because actually some of those unknowns need skills that they don't know. And that's kind of where you're seeing some of the success coming forward in those big companies, because they have that freedom to worry about the crazy stuff and the big stuff and the funky stuff.
Any more questions in the room? In fact.
So I read an article a long time ago that said that just 1.2% of the Sahara Desert can be used to power the entire world in solar energy. So I just wanted to hear your thoughts on that and why we haven't achieved that yet.
Oh, p squared equals I squared, r squared, isn't it?
Something like that.
Yeah.
Thanks, Sam, for a great question. And actually, this is the system-based approach. So actually, globally, there's organisations like the Active Building Centre that were looking at how you could use energy in places like the Sahara to convert some new materials so that they were endothermic, so they stored energy for you, and then you could ship them back where they were needed, somewhere cold to warm during winter. So actually, these are big questions that engineers are asking themselves. Batteries and microgrids are core to what we're doing. So I work on electric vehicles, but actually what can you do with the cells at the end? We were having a conversation earlier. And actually, again, what we're probably going to see is a bit like developing countries not having landlines, you know, and only having mobiles. Big infrastructure grids may also change, right? So there's loads of different thinking about how you can do that and do that effectively. I can't see something where you do ship materials across the world because I can't see how that would work from an LCA point of view.
Yeah.
But you know, it's actually the fact that we're thinking about those things right now. Yeah, it's a challenge. One of the projects actually I'm working on at the moment, which is just coming up to a competition, just in case you're all wondering and you want to be super clever, is how to replace diesel gensets with something that's sustainable. And so that's probably a combination, can be a combination of wind power, solar and battery, so that actually you don't need a diesel generator somewhere remote, or in, for example, in the centre of London, if you're working on construction projects, diesel generators give you air quality issues. So actually if you can have a non-diesel generator, then you've got some really big markets out there as well.
Excellent. Any more?
I was the worst person to ask questions. I was exactly in the middle of the room.
Oh, thank you.
Cheers.
There's another one of the ones like that.
So I guess this question is on behalf of the formal student team here, and epistemology related, because our team and formal student in general has this very interesting quirk when it comes to management, which is an incredibly high rate of personal turnover because, you know, we're a student-run organization. In each year we graduate, we go on placements, we go off to wherever. And that, of course, you understand what that means, knowledge retention. So I was thinking if you could offer some advice to a student team on how to improve that aspect. I know this is almost as bad as the one sent in by Anonymous, but
yeah. As somebody who works in government, this is actually a little bit more my ballpark, right? So, so I would work with pollution prevention and control officers. They're an interesting bunch, and local authorities that do things like regulate crematoria, dry cleaners, mobile crushers, maggot farms. Really nice. And actually, the breadth of industry is massive that they deal with. And actually, in some of the more rural ones, you might have anything from somebody doing it half time, so only 2-3 days a week, to the bigger councils like Cardiff might have a team of 6. But you're covering something that's vast, and you have turnover, and you're covering the whole country in the UK, and so it's difficult, right? And you've got this, and that's where the community practice comes from, actually. So they were using an email system just to email everybody on the circulation list information. And they moved online onto a hub so that actually they could have a messenger, so that you could have themes for conversations that then people could go and read. So I can go read back and see what the hell they did for, I don't know, the pajama jump party from oh no, let's not go that there.
No,
but
those pictures are online.
But you can then go back and see some of that knowledge, because it's conversational knowledge. And you could have a document library alongside. Government sponsors something called Knowledge Hub, which is how local authority officers do it in that discipline. But you'll find social workers, paramedics, lots of different disciplines, trying to find places where they can harbour that information. So as people find stuff out, it doesn't always get lost. Yeah. So there's a thought. So find some online way of doing it, particularly if there's a chat function that's easy for you to use. So Teams, we see. SharePoint, they've all got these sorts of functions, because if you can listen into somebody having a difficult conversation, you can learn from that. And
I think Discord is the preferred way these days.
Yeah,
I think.
I'm sure that's a Leicester.
Yeah. No, I use Discord.
Okay. Oh, so you can invite Jack.
Yeah.
And she can tell me all about it.
Thank you.
Awesome.
Yeah, thanks for that lecture. I wanted to ask, about getting the tacit information. While we're looking at the processes you explained, being able to ask the right questions to get some information from the experienced folks before they leave and leave with all that experience, can we also have, or is it already in practice, that these more experienced people have a platform where they can actually document some of their key skills or experiences, without anyone having to probe it out of them, in a sense? Because as much as you would want to ask the right questions, and they would help, obviously, like you've explained, there might be areas that you may not think to ask. And this expert, if you were to maybe if he or she had to write a book, a memoir at some point before they retire, that might be like their chapter 1, because that's something they really treasure as an experience. Yeah. But it might not be something you would think of as an intern or a junior staff to ask them about. And then how do you get that information?
Have you ever asked an older operator to write a book for you? Memoir?
I don't think it'd be printable. Some of the ones I knew. Yeah. It's a good question, but the problem with tacit knowledge is some of it is so ingrained in your unconscious, you yourself might not realise that somebody would want to know that.
There's a great example, right? So Trostra Tin Works was coating steel with tin, and one shift would have a much higher quality performance always. And so the graduate engineers had worked this out, that B shift was the one, but they also worked out that the older guy was about to retire. So being really clever, they got engineers to go and sit with him, work out what he was doing differently. And nobody could work out what he was doing differently. And they were really struggling to work out why the quality always went up when he was in and always went down when he was off. And he retired, and the quality went down and down and down. And so they rang him up and said, please, would you come do some more shifts? Because the quality is awful, 1, and 2, we want to really study you really, really, really hard. And it was actually a graduate engineer who was sat there and noticed at the end of the shift, the only thing he did different was he drank tea from a flask rather than a mug, and at the end he would pour the rest of his flask of tea, including tea leaves, into the bath. And actually now they add organic nucleating sites into tin baths, right? This is sort of explains how difficult this can be.
Yeah.
But actually engineers try and capture this, and they capture it normally within business management systems. So if you ever work on QS 9000, there's lots of detailed process flows. And I think what we're trying to say on all of those is the more you can record and the more you can be interested in actually how they're doing it. If you can write a process for making full finish exposed steel without the operators, and you will not write something that works or they use. And that's kind of where you're trying to get here with a combination of emotional intelligence, understanding knowledge, understanding sustainability. Is you've got to think in a much more holistic way to get those results.
But there are, companies they encourage people to kind of, certainly in LB Foster, we have people who are acknowledged experts who will write training courses. So they will train, they will do the onboarding training for technical or engineering or sales. So they'll write training material, but then that's kind of grows organically as each new person comes on and they ask another question. Then you can say, oh right, yeah, I've not really addressed that before, and kind of constantly evolve that training material. Teams has a wikis function, so you could use Teams to kind of add snippets of information as you get them. I use OneNote a lot, so not just for meetings, but if I'm looking at a website, I'll just kind of take a snip and say, oh yeah, that'll be useful information in the future, and just kind of build up that knowledge. And it's there, it's on OneNote, I can share that, I can publish that. So there's lots and lots of different tools.
Go back to the communities of practice actually, and your issue, and how do you keep that knowledge? Wikipedia's got one of the best descriptions of a community of practice. and the theory behind it and what you need to make it work. And that's what's one of the ways organic knowledge grows. That's a really good one for you to go and read, just because it'll give you a feel for, if we're going to do this, why are we doing it, and how can we make sure it continues beyond just us? And that's really what you're asking, isn't it? How do you make sure individuals don't just walk away and let things fall, which is, it's a waste, right? Don't like that as engineers.
I think we should probably let Jackie get some food.
Indeed, yes.
Oh.
Yes. So I think we have come to the end of our lecture and Q&A. So thank you very much, everyone, for attending. And can we also thank our speakers once again?